Hello, welcome back to Studying Science. Today's topic, reflection of light from a smooth and a shining surface. We know what is reflection of light. So when ray of light, we are considering a ray of light because if you consider a light source, let's say it's a light source and lots of light rays are coming, right? Lots of light rays are coming. But for our convenience, we should take one or two, three light rays. So because we need to draw the diagram systematically, more effectively. Hence, we can use one single ray or another ray, two rays. So let us draw for one ray and let us see how actually a reflection of light takes place from a smooth surface. So we know a smooth surface is something like that which reflects light after light falls on it. So it means that bouncing back of light happens. Bouncing back of light. And now, so can you tell me an example of smooth surface or shining surface? Yes, plane mirror. It's a very common actually material, plane mirror, and every day we use it, right? So plane mirror, we can write like a plane mirror surface like this. This is our plane mirror, and if a ray of light, we are considering a ray of light, so it falls. Remember, you have to always give the direction of light because it indicates that the light ray coming from this direction and it is going towards this direction, right? Towards the surface. It is called M1. So this is a smooth surface. After the light ray strikes the mirror, bouncing back of light will happen. So it will reflect back. It will back from the mirror surface and it will move into the another direction. Let us draw it. Okay. Now see, I have given the direction of light on the upwards. So initially it was downward direction. Light was falling on the mirror surface, and after reflection or after bouncing back of light, it goes upward. So here, this point is very important. At this point, reflection of light takes place. Correct? Now, let us see the point where the incident light, so the point where the light actually strikes, on that point we will draw one line perpendicular to this surface. Okay, this line is imaginary line and it is known as normal. So normal is drawn at the point of incidence. So what do you mean by incidence? When the ray of light, let's say this ray of light 1, when the ray of light is striking at the point, let's say it is point O, then this point O is known as point of incidence. And now after reflection, the ray goes off or in any direction, right? Let us say it is ray 2. Now let us understand a few terms. Since this ray 1, when it is falling on the mirror surface at point O, this ray is known as incident light. ray 1 is known as incident light or incident ray. Right. Now, what about ray 2 after reflection? Reflected light. Ray 2 reflected ray or reflected light. Correct? So, this is normal. We can write NO normal. NO normal. It is drawn perpendicularly on the mirror surface at the point of incidence. So O means point of incidence. Okay, so you can take this experiment, you can do this activity at home. Maybe you can take a laser light. I have one laser, just a minute. See, I have one laser. Wow, it's a very high beam light, single beam light, right? So you can take a mirror strip or plane mirror, whatever mirror you have at home, plane mirror. So you can do this easy activity and you can verify this incident ray, reflected ray, and so on. Yeah, we are coming back. So we are coming slowly on this topic. Now the thing is that we'll learn a few terms related to reflection of light. Now ray 1, see, the angle made by ray 1 with the normal. So this angle. So let us write with some another marker. The ray 1 with the normal makes an angle. Let's say this is I. This angle is known as angle of incidence. Angle of incidence is the angle made by the incident ray with the normal. Similarly, the angle made by the ray 2 or the reflected ray with the normal is called R or angle of reflection. R. Angle of reflection. I is equal to angle of incidence, R is equal to angle of reflection, ray 1 is equal to incident ray, ray 2 reflected ray, NO normal, O point of incidence, and the most important thing, this is the plane on which the mirror has been kept. The plane is very important term in physics, plane. So now there are two laws related to reflection of light. First law, angle of incidence always equals to angle of reflection. So it becomes I is equal to R. First law, incident angle is always equal to reflected angle. Clear? Second law, the incident ray, reflected ray, and the normal drawn at the point of incidence are all on the same plane. This is the second law of reflection of light. Ray 1, ray 2, and normal NO are all on the same plane. So it means that, suppose I have one plane, right? So on this plane I have kept a mirror, okay? So if I disturb the plane, if I displace the plane from its original position, it means that the ray 1, ray 2 will be disturbed, right? Because normal is imaginary line, right? So it will not be disturbed so directly. But definitely ray 1 and ray 2 will be disturbed because ray 1 is falling on the plane and on which the mirror has been kept. Clear? Good. So this law is very important. Ray 1, ray 2 and normal are all on the same plane. Correct? There are a few more terms on this concept. Now see, what I have told you, this is our mirror surface and the normal, drawn, obviously it is perpendicular then, it is perpendicular 90 degree. So now what about this angle? Let's say this is, let's say P, and let's say this is Q. So angle POM, angle POM. How do you find? Similarly, 90 minus I, 90 minus I. This angle is known as glancing angle. This angle is known as glancing angle. Glancing angle. So the glancing angle we are trying to find out with respect to incident ray. So it is known as glancing angle of incidence. Similarly, we can say this angle, it is known as glancing angle of reflection. QOM1, glancing angle of reflection. Right? Angle POM, glancing angle of incidence. Angle QOM1, glancing angle of reflection. Sometimes some numericals might come. So find the glancing angle of incidence. Angle of incidence is given, let's say 60 degree, and what about the glancing angle? Then obviously glancing angle G, it is written as G, you can say G is equal to 90 minus 60 is equal to 30 degree, right? Good. So we have learned many things. Incident ray, reflected ray, normal, point of incidence, angle of reflection, then glancing angle, normal, the two laws, law 1 and law 2, angle of incidence always equal to angle of reflection, and the second law, that all lie on the same plane. So all means ray 1, ray 2 and the normal drawn at the point of incidence. That is another important thing that I want to highlight. Now let's say this mirror is not present here. Let's say, suppose. So without the absence of mirror, if I extend back the incident ray, what would happen? So I'm just extending back. Right? Without mirror. So it could have gone towards this direction, right? This ray PO, correct? Now this extended ray, it makes an angle with the reflected ray. Remember, this extended ray, so we have traced it back without the absence of mirror. So we are just thinking. So this ray makes an angle with the reflected ray. Let's say this angle is delta. Delta is known as angle of deviation. Delta is known as angle of deviation. angle of deviation. So deviation means, you obviously you know, right? So when actually, so mirror is there, how much light bends from its original path. So that is called angle of deviation. Simply see how to find this angle. Simple geometry. It is normal, so you just extending back. So it is I. So obviously this is also normal. So this should be always I, right? These two angles are equal as from the concept of geometry, because this is perpendicular. This line, it is just uh, falling obliquely, right? Just see the concept here. So this angle and this angle must be equal, right? So if this angle is I, then what about this angle? Do you know this angle? This angle is equal to glancing angle. Glancing angle, I mean 90 minus r. And what about this angle then? So this angle means 90 minus I, correct? So we are writing here, for example, let's say delta is equal to, first I need to measure this angle. It will be 90 minus I. First let us write 90 minus I. Okay, this angle plus this angle. This is 90 minus r plus 90 minus r. What is coming? So it is coming 180 minus I minus r. This is my angle of deviation. So sometimes numerical might come and you have to calculate accordingly. So this is the main actually concept regarding the reflection of light. And now tell me if you have any doubt, just pass the comment in the comments panel section. Then definitely I'll try to answer those questions if you have any doubt. So plane mirror is a very powerful example, you know. And in our next class, we'll try to figure out the image formation by plane mirror. What type of image is getting formed by plane mirror? So we have studied image is of two types, real and virtual. So is real image is getting formed by the plane mirror or virtual image? We'll try to find out through geometry and through some characteristics. Okay, so I hope this concept is cleared, right? Yeah, so see you in the next class by the image formation by the plane mirror. So yeah, take care and bye bye.